Hey guys, this video is about isotopes. Now isotopes are atoms that have the same number of protons and electrons, but a different number of neutrons. So this implies one thing. Have the same atomic number, but a different mass number. So you cannot use the mass number that's found on the periodic table when it comes to isotopes. The reason why is because they're going to be expressed in hyphen notation. This is where the element is going to be written, or the isotope, and next to the isotope there is going to be a dash and a number. That number after the dash is the isotope's mass. So for example, carbon 12 and carbon 14. You're not going to find carbon 14 on the periodic table. Okay? So this 14 expresses the mass for this specific isotope. Now, they do have the same atomic number, and that's found on the periodic table. So carbon has the atomic number 6, so they both have 6 protons. Okay? However, the mass number is different. So they are going to have a different number of neutrons. So let's do a little practice here. Let's look at 3 isotopes of hydrogen. So we have hydrogen 1, hydrogen 2, hydrogen 3. Hydrogen 2 is also known as deuterium, and hydrogen 3 is also known as tritium. Now, the atomic number from the periodic table, I'm just going to fill in the table here. Is simply 1 for each of them. Now the mass number is going to be indicated by this number right here. Okay, that's number 1. This number here is going to be the mass number for that second isotope, and this number here is going to be the mass number for this isotope. So from the periodic table we see it has the atomic number 1, so that means it has 1 proton, 1 electron. And they each have 1 proton and 1 electron because they share the same atomic number. Now the number of neutrons is the mass number minus the atomic number. So in this case it's going to be 1 minus 1, that equals 0. Okay, for the next one it's going to be 2 for the mass number minus the atomic number 1, and that's going to be 1. For hydrogen it's going to be 3 minus 1, the atomic number, and it's going to be... The next example is the 2 isotopes of sodium. Okay, so we have sodium 23 and sodium 24. On the periodic table, if you look, you'll find that sodium has the atomic number 11. Okay, so we write 11 for the atomic number. And they both have the same atomic number. Now the mass number comes from the number after the dash. In this case it's 23. And in this case, for this one here, it's 24. Okay? Now looking at the numbers that we got, the atomic number tells us we have 11 protons and 11 electrons. Remember, they equal each other. 11 protons, 11 electrons. Now to calculate the number of neutrons, you take the mass number minus the atomic number. So 23 minus 11, and that equals 12. And for this one, we have 24 minus 11, and that's 13. Okay, so we can compare the 2 isotopes of sodium now. On the left, we have sodium 23, and on the right, we have sodium 24. Now notice the 2 red clouds are the clouds of electrons, and there's 11 electrons here and 11 electrons here. Inside the nucleus, there's 11 protons, 11 protons. But there's 12 neutrons here and 13 neutrons here. That's what makes isotopes different, okay? Isotopes have specific uses. Okay, what I want you guys to do on your own is calculate only the number of neutrons for the following three isotopes. Now, you have neon 20, neon 21, and neon 22. So I want you to calculate just the number of neutrons for this. So pause the video. Okay, so let's check it out. Let's see how you would do this. All right, so you have 20 for the mass number for the first isotope of neon, minus 10, which is the atomic number. So you get 10 neutrons. Neon 21 has 21 for the mass number minus 10, the atomic number. So this one has 11 neutrons. Neon 22, so we take the mass number 22 minus the atomic number 10 and we get 12 neutrons. So you can see they all have different numbers of neutrons. So that's why they're isotopes. These also have specific uses. And that's it for right now. All right, guys.